Hello students, so we will continue our lectures on interpolation techniques. So in our previous lecture, that is lecture number 228, we started uh, Lagrange's polynomial, Lagrange's interpolation technique, and we derived the polynomial fx as equal to b1 plus b2 x minus x1 plus b3 uh, x minus x1 and x minus x2, where the value b1 is equal to fx1, the coefficients, b2 is equal to fx2 minus fx1 divided by x2 minus x1, and b3 is equal to fx3 minus fx2 divided by x3 minus x2 into x3 minus x1 minus fx2 minus fx1 divided by x2 minus x1 into x3 minus x1, and this is nothing but your b2, so you can write it as minus b2 divided by x3 minus x1. So this was the polynomial that we obtained. Now the calculation of the coefficients may be further simplified by assuming the following form. So we go to third degree polynomial in this case. So we can write fx is equal to c1 x minus x2 into x minus x3. But this is actually not a third degree polynomial, but a polynomial represented in a different form. Plus c2 x minus x1 into x minus x3, and plus c3 x minus x1 into x minus x2. So it is 2 and 3 here, x2 and x3, so put it as 2 3. This is 1 3, and this is 1 2. Now here the values, the coefficients are represented as c1 can be represented as equal to fx1 divided by x1 minus x2 and x1 minus x3. C2 can again be represented as fx2 x2 minus x1 and x2 minus x3, and C3 as equal to fx3 divided by x3 minus x1 into x3 minus x2. So you can see the pattern here. So if it is in C1, if it is in x1 and x1 minus x2, x1 minus x3, if it is C2, it's in x2, x2 minus x1, x2 minus x3, and it's 3, it is x3, x3 minus x1, x3 minus x2. And you can actually write the whole polynomial then in the concised form. You can write fx as equal to summation I 1 to 3 fxi into pi, that is multiplication j is equal to 1, I is equal to 1 to 3 x minus x j divided by xi minus x j. So this is how you can write the polynomial, and this is nothing but the Lagrangian polynomial. So let us see an example of this polynomial. Now we have been given a table of x versus fx. That means x and fx. The values of x are 1.5 and 3.0 and 6.0, and the corresponding values of fx are minus 0.25, 2.0 and 20.0, and the problem is to find the value of fx at x is equal to 4. That means we have to find the value of f4, which is not given. So it is in between these two regions that you will get a 4, and to find the value this region. So if you use the Lagrangian polynomial, that means if you use fx as equal to let us write the function once again. So it is summation I 1 to 3 fx I into pi ij 1 to 3. We write this form as x minus xj divided by xi minus xj is the form. So if we expand it, this becomes, so the first one will be our fx1. This is the first corresponding to I is equal to 1. Then it will be summation x. So since I is equal to 1 and it moves from 2 to 3, so it will be x minus x2 and x minus x3 divided by x1 minus x2 to x1 minus x3 plus it will be fx2. So it is 2 here, so it will be 3 and 1 and 3 here. So since it was 1, it was 2 and 3. Since it is 2, it will be 1 and 3. So it will be x minus x3 and x minus x1, and it will be x2 minus x3 and x2 minus x1, and plus the last one x3. So it will be x minus x1 into x minus x2 and x3 minus x1 into x3 minus x2. So if we put all the values, so we have the different values. We have this is x1, this is x2, and this is x3, and this is fx1, this is fx2, and this is fx3. So if we put the values, it will, for example, this value fx1 is minus 0.25, and this x2 is 3, and this is your 6. So putting all the values, the first value is minus 0.25, then there will be 2, it will be x minus 3 and x minus 6 divided by the value of x1 is 1.5, so it will be 1.5 minus 3 into 1.5 minus 6 plus the second value is 2, this is fx2, it will be 2 minus 1.5, x minus 1.5 and x minus 6 divided by 3 minus 1.5 into 3 minus 6, and plus the last one, that is 6 into x minus 1.5 into x minus 3 divided by 6 minus 1.5 into 6 minus 3, and this value comes out to be equal to 5.999, which is approximately, you can say, as equal to 6. No, sorry, it's not. It will be 6 and so what we will do here, the only unknown here is the this x value. So we need to find out the value of f4. So that's how we put x is equal to 4 here, and then we get the value of f4 as equal to 5.999 is the value 6. So this is the solution. Now this is the arithmetic part. What about the algorithm? The algorithm can be presented in the following. First, we need to find the value of x. That means here, let's take the previous example. There are I is equal to 1 to 3. So let's write the function once again. Fx is equal to, first there is a summation from I is equal to 1 to 3. 1 to n, for example. This can be more than 3 also. let's take the value is n fx I, then there is ij 1 to n x minus xj divided by xi minus xj. Now for arithmetic we need to, although it is n, we need to add an extra step so that the program actually stops. So what we'll do, we'll add an extra +1 here. So the algorithm will be, first step of the algorithm we have to is to find the value of x and then find the value of n. So like in the previous case, it will be 3 and it will be, the value will be 4, because that's the value we need to find out. So first will be read x and n. Then we will do the loop, that means for loop, introduce for loop and introduce a parameter I, which will run from 1 to n plus 1 and in steps of 1. Then we will introduce a parameter sum, which we will assign a value 0, and then we'll again start the for loop, that means from I to n plus 1. We will use the product function, which we will assign a value 1, and then again we will use the for loop for j to n plus 1, because there are I and j both involved here, both in steps of 1 and steps of 1, and then we will use the end for statement here and also an end for statement here, and then we will write the sum as equal to sum plus the function fi into the product function, and then we will write end for, and then we will write, ultimately the answer that we will get is write x and sum, and then we will stop. So let's try to understand what it is taking. First of all, it is considering the value x and n here. So taking the previous case, x is 4 and n is 3. Now let's understand the summation. So from x3, the first value is fx1, and then it's x minus x2 and x minus x3. So that is how it is. For I is equal to 1 to n, we are considering the sum here, only the sum part, and between the sum we are doing the product of I and j. One step is missing here. We need to write the product function here is equal to product into x minus xj divided by xi minus xj. That means this part This is for I is equal to 1 to n plus 1 and j is equal to 1 to n plus 1. This is the product function. Product is equal to product into x minus x I divided by xi minus xj into xi minus xj. So this is the product function, and this is the sum function. That means for I is equal to 1 to n plus 1, sum is equal to sum into fi into this product function. So that's how we get the whole algorithm. And ultimately we introduced 3 for loops. This is for the sum, so n for, and so this is for the summation. I is equal to 1 to j, 1 to n plus 1, and there are 2 for loops for pi I j 1 to n plus 1. Ultimately we get the final solution.